Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Today we will see the overview of advantages of single linked list, followed by disadvantages of single linked list, and we will be seeing the applications of single linked list also. As we have seen in the previous lectures or previous sessions, we have discussed about single linked list, how we are going to perform creation and display operations, and with that we have seen about all insertion operations and followed by deletion operations also. You can once refer the previous videos before going to look into these advantages, disadvantages and applications. Yes, let us see about what are the advantages of a single linked list. The main advantages are it is dynamic in nature. Let us see the overall points, then we will be discussing about each point in detail. Dynamic data structure and no wastage of memory in this single linked list, and you are going to perform implementation of some of the data structures using this single linked list. And we are going to perform insertion and deletion operations, as well as it will be a flexible one and efficient for large data. We are going to use this linked list, and it is scalable. These are the main points where we are going to have. Now in detail we will be seeing about what is this dynamic data structure is. Here, dynamic data structure, as we have seen different types of linear data structure, under that we come across arrays and linked list followed by stacks, queues and everything. And in this, array is a static data structure, as we have discussed in the concept of arrays, right? And now we are coming to the linked list. In this, the data which you are going to use, the data structure which you are going to use is of dynamic in nature. Why it is called it as dynamic in nature? Let us see. A linked list is a dynamic arrangement, so it can be grow and shrink at runtime by allocating and deallocating the memory. So there is no need to give the initial size of linked list. In the array, when we want to use the array, there we need to specify the size of your array. At the starting itself, we need to specify the size. That is nothing but the static representation. But in the linked list, no need to specify any size. Here, the memory will be allocated at a runtime, right? Based on this, the size of memory, whatever you want, that can be increased as well as you can decrease it. And whenever we want to allocate the memory, it will be allocated. If you want to deallocate the memory, we can deallocate it and use it for some other purpose. That is nothing but by using free function, we are going to deallocate the memory. Okay, this is how the dynamic data structure will be one of the advantage of a single linked list. And one more advantage here is, here we are going to have no memory wastage will be here. No memory wastage will be here. That is, in a linked list, efficient memory utilization can be achieved. Since the size of linked list increases or decreases at runtime, so there is no memory wastage and there is no need to pre-allocate the memory. The same thing what we have discussed in the previous dynamic data structure, this comes into the same. When I am going to allocate the memory dynamically, because of that, no wastage of memory will be there. How much memory that is required for us, that much will be allocated at runtime, right? This is how the memory wastage will be happen. And implementation, by using this linked list, single linked list, we can implement some of the linear data structures like stacks, queues, and we are going to have some other applications. Some of the data structures can be implemented. Mainly we will be seeing about stacks and queues here. And then coming to the insertion and deletion operations. Here, insertion deletion operations are quite easy in the linked list. Why? Because there is no need to shift the elements after the insertion or deletion of elements. Only the address present in the next pointer needs to be updated. As we have seen in the array, if I want to insert any element, means I need to shift the elements to the right hand side, and I need to provide some memory over there, and based on that I am going to insert the element into that space. If the same thing, if I want to delete an element, then I want to shift to the left hand side. This has to be done. But in the linked list, no need to be done with that. No need to perform any shifting. Just we are going to work with the addresses wherever the pointer is required, or wherever the node to be inserted. By using that address, we are going to link and we are going to update it. Right? That is how insertion and deletion operations are going to be one of the advantage with a single linked list. And flexible. This is because the elements in the linked list are not stored in continuous memory locations, unlike array. In the array, all the elements are going to be stored in the continuous memory locations, right? But here, this is not going to be like that, because we are going to allocate the memory from different places, and we are going to make some link based on the addresses. Because of that, it is flexible, right? And efficient for large data. When you are going to use large data sets, in that particular case, we are going to use linked list. It will play a crucial role as it can grow or shrink your data dynamically. If I want to increase my data set, or when I want to decrease the data set, it is possible because of the linked list concept, right? Scalability. Contains the ability to add or remove elements at any position, right? But when I want to perform insertion or deletion, or if I want to add or remove some elements at a particular position, it is easy to be done in the linked list. But when you are going to see that with the arrays, it is a little bit difficult. Why? Means we need to shift the elements to the next locations, and we need to provide some memory over there. Then I want to perform insertion as well as deletion. This has to be done, right? This is the advantages where I can say some of the advantages of a single linked list. The same thing may be applicable to most of the linked list, like a double linked list and circular linked list also. There we will be seeing some more advantages with our double linked list as well as circular linked list. Yes. Coming to the disadvantages of a single linked list. Here, memory usage. First thing is memory usage. More memory required in the linked list can be compared to an array. When I am going to represent an array, I am going to store the elements in this continuous way. Suppose 20, 30, 40, 50, like this, right? But when we are going to see about the linked list, for one element to be stored, we are going to have the data value will be stored in this location, and we are going to store the address in this part. Some extra memory we are taking here, right? Because in a linked list, pointer is also required to store the address of next element, and it requires extra memory for itself. This may be considered as one of the disadvantage. When I want to have a linked list, it should maintain the address of the next node to be stored in the node address part, right? Because of that, there will be memory usage will be little bit waste. Okay, and traversal. Let us see the traversal how this is one of the disadvantage with the traversal. In linked list traversal, it is more time consuming as compared with an array. If I want to access an array element, a particular array element, if I want to access 40, by using this index of a of 2, I can access it. But here it is not possible with the linked list, because you need to direct access to an element is not possible in a linked list as in an array by index. What I said is the previous statement. For example, for accessing a node at a position n, one has to traversal through the nodes before it. Suppose if I am going to have the nodes like this, I am going to have some 4 nodes. If I want to access the element of this one, I need to traverse through all these 3 nodes. Then only I can able to access this 40, right? This is one of the disadvantage where you can find. And one more disadvantage with the single linked list is reverse traversing. Reverse traversing is difficult in single linked list. As we are going to see, we are going to have only one direction from one node to the another node, right? If I want to traverse through this list from backward onwards, from here to here, I want to traverse 40, 30, 20 and 10. It is very difficult. That's why we are going with the concept called double linked list. Okay. But it is in the case of double linked list, it will be easy. Why? Because it is possible as it contains a pointer to the previous connected node also. We are going to have the previous connection also present in the double linked list. Because of that, it will be very easy for us to traverse in the reverse traversing. But in the single linked list, it is difficult. For performing this, extra memory is required, the back pointer, hence there is a wastage of memory. And because of backtracking or back pointer moving, we need to use one more extra memory space. Because of that, this may be one of the disadvantage you are going to find with the linked list. And random access is not possible in the linked list due to dynamic memory allocation, as we have seen in the previous example also. Okay, these are the disadvantages of single linked list. Coming to the applications of single linked list, where we are going to use this single linked list. Okay, let us see. First one we are going to use in implementing stacks and queues. Single linked list can be used in implementation of stacks and queues. In stacks, elements are added and removed from only one end, while in queues, elements are added at one end and removed from another end of the list. As we have discussed these concepts already in the unit 1, stack using linked list and queue using linked list, stack using arrays and queue using the arrays, and we can be used to implement this stack using arrays, stack using linked list and queue using linked list after completion of this concepts, single linked list, double linked list and circular linked list. There you can verify how we can implement this stack using linked list and queue using linked list, right? And implementation of stacks and queues can be done by using the linked list concept. And navigation in web browsers. If I want to navigate from one browser to another browser, right? In this also we can use this single linked list concept. Single linked list can be used to store the browsing history. Whatever the web pages I have opened, right? In the history, it will be stored by using stack. It will be stored which pages you have opened in the web browsers, right? Each URL visited is stored as a node in the list. Whatever the URL you are going to visit, that will be stored as a node in the list with the next pointer pointing to the next URL visited. If I am going to move from, suppose I have opened Google, then I have opened LinkedIn, then I have opened Facebook, like this, right? This will be stored in node list. Based on that, you can see that which of the browsers which you have opened, right? By using this, you can see this is one of the application of single linked list. And implementing in music player, everyone is using music player, right? There also the single linked list comes into the scenario, right? How this will be useful, this will make one of the applications of single linked list. You are all listening the music, right? To enable the user to easily navigate between the songs. Suppose I have a list of 10 songs. In that, I want to listen all the 10 songs in a continuous fashion. In that case, what happens? Each song in the playlist is stored as a node in the list. It will be stored with the next pointers pointing to the next songs in the list. Immediately after completing of the first song, it will be moving on to the second song. Then after completing of the second song, it will be going for the third song. Like this way, a continuous songs you can listen up to in the list how many of the songs you have stored. In the continuous fashion you can store, right? This is one of the application where you can see. Let us see the summary of today's session. Advantages of single linked list. We have seen few of the advantages of single linked list regarding dynamic memory allocation, no memory wastage, insertion and deletion operations, how we are going to perform, right? And these are some of the advantages we have seen. While coming to the disadvantages, there will be a wastage of memory when we are going to use the linked list. We need to use some extra memory space for the address to be stored, right? Because of that memory wastage will be there. And random access cannot be done based on this single linked list. Random access cannot be done. right? And applications where we have seen in music players, we can use this single linked list, and implementation of stacks and queues, we can use this. And lastly, we have seen in web browsers, web browser history. If you want to see, then we can use this single linked list, right? Thank you. If you have any doubts, please do it in the comment section. Thank you.